Welcome to Swayamprabha, sponsored by MHRD New Delhi and conducted by IIT Madras. Channel number 15, course title Pharmaceutical Organic Chemistry 1, lecture title Classification, Nomenclature and Isomerism, that is part 3, and module number 1, lecture number 3, that is M1L3. This course, it is as per Pharmacy Council of India, New Delhi syllabus, and it is beneficial for first year students in second sem. Myself, course coordinator, Mr. Dhamak Vikrant Murlidhar, affiliated to Savitribai Phule Pune University. Name of academic expert, Dr. Ramesh L. Sawan sir. Project name DTS Swayamprabha, sponsored by MHRD, New Delhi. Let us see the learning objective of this session. In the last session, we have studied the IUPAC nomenclature of some compounds or some classes. In this session, we will study IUPAC nomenclature and for its rule, that is aldehyde. Secondly, it is ketone, carboxylic acids, esters, amides, and anhydrides. So these are the classes that we will study in the session. Now let us see the content of this session. Rules for IUPAC nomenclature of aldehyde, ketones, carboxylic acids, esters, amides, and anhydrides. These last three classes, ester, amides, and anhydrides, these are the carboxylic acid derivatives. By some modification in carboxylic acid derivatives, we get these three compounds, and by modification of IUPAC nomenclature of carboxylic acids, we get these three compounds. And these are two independent classes, that is aldehydes and ketones, and all the classes, they are containing carbonyl functional group in them. We will see the rules as well as an example from each class. Let us see IUPAC rules for naming of an aldehydes. Now we have started the first carbonyl compound, and in this session we will see the remaining carbonyl compounds also. So the first carbonyl compound we will see, that is aldehydes, and aldehydes in IUPAC, they are named as alkanals. So instead of an alkane, as in the earlier cases also we have seen, alkane E, it has been dropped, and instead of that E, it has been replaced by Al. Don't confuse with OL. OL, it is for an alcohols, and Al, it is for an aldehydes. So remove this E and just put Al. Now let us see one of a common example, that is the common name for such kind of a compound, it is formaldehyde, and in case of an IUPAC nomenclature, they are called methanals. Whenever we are considering the carbonyl functional group, we have to consider the carbon. So that is why it will become an methanal. Instead of N, we are just putting Al by dropping E. Now one more example I will take, that is aldehyde has one hydrogen on the adjacent side, or it has two hydrogens. So there is only one compound, that is formaldehyde or methanol. It is having adjacent hydrogen on both the sides, or otherwise it is having an hydrogen on one side at least. So the name of this compound, it is ethanol, as it contains two carbons, so that is why ethanol. Now we'll see one more example in this class. As we have seen in the earlier cases also, that we have to select the priority. But before that, we should remember the IUPAC nomenclature rules, commonly IUPAC nomenclature rules. That is, we have to select the longest chain. So this is the longest chain. Sorry. So this is the longest chain, and after selecting the longest chain, give the name of that longest chain and number it and identify the substituent as per the numbering. So I will start numbering from this carbon, as I have told you in earlier cases also, that this CS3, it is having the least priority. The highest priority it will be for an aldehyde in this compound. So I will start numbering over here: 1, 2, 3, and 4. At 3 position, we can see that it is having a methyl substituent. So I will write 3-methyl, as there is no other substituent now, only it is a methyl. And after that, it is butane. So I will write butanol. So instead of E, I will write Al, butanol. And there is no need to write the number of an that butanol, because as it has been understood that it is not a ketonic group. Ketonic group, it will be in the middle, or but in case of an aldehyde, it will be always at the end. So it will always start from 1. In the mixed example, how to give an priority for such kind of a group, we will talk about it also. Let us take one more example. In this case, we are having two kinds of an aldehyde groups. So there are two aldehyde groups, and they are at both the ends. Already I have told you that aldehyde, it will be always at the end. So for naming of such compound, there are two dial Al. There are two aldehyde groups, so it will be dial, and we have to locate the position of that aldehyde group now, as it is at two different positions. So I will start numbering from here. You can start numbering from anywhere, as both are on the same site or same cases. If I start numbering from here, it will be same. This carbon, it will be 6 number carbon. So now count the number of carbons. So it is 6. Now I will write the numbering 1, 6. Hexane dial. We have seen in case of an alcohols in the last session that whenever we are writing dial, that E it has been written. In case of an diols and triols of an alcohols, we have seen such kind of an things that E it has been written. So same thing happens in case of an aldehyde, that E it is written when it comes dial. When it is single, then we have to drop E and write Al. Now we will see IUPAC rules for naming of ketones. Ketones are named as alkanones. Ketones are named as an alkanones. We will see one of the famous example, or the smallest example from this class, that is CS3, C double bond O, CS3. So ketones cannot be small than this. Commonly it is said to be an acetone, very common lab solvent that you might be using, or it is also called dimethyl ketone, as it is having methyl group on both the sides of a ketone. So this is a ketonic functional group in the middle. It is also called R, C double bond O, R. The name of this compound as per IUPAC, it will be, there are 3 carbons, so it will be propanone. Instead of E again, instead of like in case of an alkane, instead of E, we have to write O and E. in case of an ketone. So drop this E and write O-N-E in front of it. Now we'll see one more example. Suppose CH3, CH2, C double bond O, CH2 and CH3. So this compound, it is having 5 carbons. So the name, like it is in case of an alkane it will be an pentane, but it is having a ketonic functional group at the middle. If I locate the ketonic functional group by numbering, firstly select the longest chain. So this longest chain, so there is no need to worry about a longest chain. After it, number it. By numbering it, you can see that oxygen carbonyl functional group, it is at the same location from both the sides. If I number from this 1, 2, 3, 4 and 5. If I start numbering from this carbon also, it will be similar. So the name of this compound, as I told you that ketone, it comes in the middle, but in case of an aldehyde, it comes at the end. Always it will come at the end, but ketone, it may come in the middle. So the name of this compound, it is pentanone. But we have to locate this ketonic group. So 3-pentanone, it is the correct name for the compound. Let us take one more example, and remember that "one" it is for it is for suffix purpose. When it comes to an prefix, it is called oxo. We will see such kind of an examples in the next session, when we will have 2 different kind of a functional group in same molecule. So at that time we will see this oxo. I will take one more example which contains a diketones. This molecule, it contains 2 now ketonic functional groups. I have to choose a numbering. Firstly, select the longest chain. So this is the longest chain. There is no any branch, and I have to select the numbering in a such way that minimally I can find out the functional group. If I start numbering from over here, it will be not correct. So I have to start numbering from this carbon 1, 2, 3, 4, 5 and 6. So these are the 6 carbons. It means the structure, it is of an hexane. Hexane means in case of an alkane, but here it is a substitution. That substitution has to be marked. So substitution has to be marked. It means I have to write the number of that substitution at where this ketonic functional group it is been present. So I will write hexane dione. So again, remember that in case of an alcohols and in case of an aldehyde, we have seen whenever it comes a di, E it is been written. So don't make a mistake of writing an E. Some student directly write dione and dropping the E. You have to drop certainly an E when it is only a single ketone. But when there are 2 ketones or 3 ketones, then you have to retain this E. The name of this compound is 2,4-hexadione. As the ketonic functional group, it is at position number 2 and position number 4 and 6 carbons, and so that is why hexane and dione for double ketonic functional group. Now we'll see the rules for naming of an carboxylic acid. So there are some more classes of an carboxylic acid. Firstly, we will see only of an carboxylic acid, how they have been named. Carboxylic acids are named by alkanoic acids. In case of an alkane, just drop E, and instead of that E, I have to join with oic, OIC, oic acid. Oic acid. Let us see one of an example. Very famous compound you might be knowing. The common name for this compound it is formic acid. Formic acid. But in case of an IUPAC nomenclature, it is said to be an methanoic acid. It is said to be an methanoic acid. I have just dropped E and written oic acid. It means that it is containing an carboxylic acid functional group. So I have considered this carbon for writing methane. We will take some more examples in this class. Suppose now in this case you can see that it contains two substituent and one substituent and one functional group. So that substituent it is methyl. I have to number this compound. So for numbering of this compound, as firstly I have to select the longest chain. So this will be the longest chain, or either this can be a longest chain. Both methyl comes at and same number. So I will select the longest chain and number it, because aldehyde carboxylic acid group it is an first priority group. So I will start numbering from there: 1, 2, 3, 4, and here it is having a 3-methyl at third position. So the name of compound it will be 3-methyl, and as there are 4 carbons, so it will be butanoic acid. 3-methyl butanoic acid. So this is the name of a compound. Let us see one more example. Again, there is an bromine substituent present, but the priority group, highest priority group, it is an carboxylic acid. So I will start numbering from here: 1, 2, 3, 4, and 5. So the name of this compound it will be 4-bromo, separated by hyphen, 4-bromo. 4-bromo pentanoic acid. 4-bromo pentanoic acid. Next class, that is esters. Ester it is one of a derivative of an carboxylic acid. Actually, the derivative it means that by little modification of an carboxylic acids, these some of the classes they have been prepared, like esters will be there, amides are there, anhydrides are there. So we will see one by one. And in case of an IUPAC, little bit name at the suffix it has been changed. Esters are derived from acids by replacing OH group by OR group. If we see the general structure of an acid, it is RCOOH, and it is for an acid, carboxylic acid, and for ester it is RCOOR. By replacing H or by replacing this OH, we have substituted this OR, it becomes an ester. And in case of an IUPAC nomenclature, now the name consists of 2 words. First word it is the name of an alkyl group attached to the oxygen, and the second word it is derived from carboxylic acid. Instead of oic acid, just keep that O, and IC it will we changed IC acid to 8. Means suppose say we are having an acetic acid, the name of structure, common name of an structure acetic acid, and the IUPAC name it is an ethanoic acid. So replace this OIC and write it 8. If suppose I will draw a structure of an acetic acid, this is the acetic acid structure. If I have to write ethanoate, it will have a little bit more modification, that is C double O CH3. The name of this compound it is methyl ethanoate. So I have replaced this IC acid to 8, and I have to write the oxygen which is having a bond with an alkyl group. That alkyl group I have to write over here, as it has been said. The first word is the name of an alkyl group attached to the oxygen, and second word is derived from the carboxylic acid by replacing IC acid to an 8. Now we will take some more example from this class. CH3 C double bond O C2 H5. So this is the compound, and now we have to write the IUPAC nomenclature for this compound. See, the part which is joined with an oxygen, that has to be written first. The oxygen part, it is an ethyl. So I will write ethyl, and the remaining part, there are 2 carbons, so it will become ethanoate. Whenever we are writing any structure of an carbonyl compound, we have to consider the carbons. The carbon which is linked with an oxygen, that we have to consider for writing the IUPAC nomenclature. Here, as there are 2 carbons, 1 and 2, so I have written ethanoate. Now coming towards the next class, that is an amides. It is also a derivative of an carboxylic acid. Amides are derived from acids by replacing OH by NH2. So let us take an example of this amide. A general class of an amide, or generally it has been represented by RC double bond O NH2. OH, it has been replaced by NH2 from an carboxylic acid. And by replacing that, we have to replace the ending oic acid, and we have to write amide. For an example, I will take this is suppose an carboxylic acid. This structure, it is of an formic acid. And now if I write the derivative of this formic acid as an amide, name of this compound, it is methanamide. So replace methanoic acid. This is formic acid, it is a common name or general name. The IUPAC name, it is methanoic acid. So replace this OIC acid, and instead of that write amide, so it becomes methanamide. Now let us take one more example. There are 2 carbons. As I told you that we have to consider the carbonyl carbon also when we are writing any carbonyl group for an IUPAC. So the name of this compound, it will be ethane, and remaining part, that is amide. Ethanamide. Now we'll see one more class, that is of carboxylic acid derivative once again. Anhydrides are derived from the acids by replacing OH by OCOR, and they are named by changing the suffix acid of parent acid to anhydride. So let us take an example, from that you will understand. Say suppose this is an example. So OH, it has to be replaced, means H, if I will draw over here, that has to be replaced by OCOR. So it will become C double bond O, and R I will write here, it is an CH3. So just change the suffix acid, as we are writing in case of an carboxylic acid, just change the suffix acid of a parent acid and write anhydride. The name of this compound, as per an acid, suppose say for an example I will draw one more acid structure. The name of this compound acid, ethanoic acid. The name of this compound, it is ethanoic acid. In case of an carboxylic acid derivative, we have seen this example, that is ethanoic acid. Now just what I have to remove, I have to remove this acid, and instead of that I have to write anhydride. But both the ends, they are similar, right? Both the ends, they are similar. So I will write ethanoic anhydride. Ethanoic anhydride. So this is the name of a compound. So whenever it will come an anhydride, both the ends, they will be similar. Say suppose we will take one more example. The name of compound, it is propionic acid. As there are 3 carbons, so it will become propionic acid, and it is having an anhydride, so it becomes propionic anhydride. Propionic anhydride. Now let us see the summary of this session. We have seen the first class, that was aldehydes, and they are named as alkanes. In the last session we have seen alcohols, and alcohols are named, instead of Al it is Ol, so don't confuse with that. In case of an aldehyde, it is having Al at the last. Second class we have seen ketones, and in case of ketone it is having O and E. Dropping E in alkane, just write O and E at the last. We have seen several examples from this class also. After that, the main class from carbonyl, it is carboxylic acid, and it is named as alkanoic acid. Drop E and write OIC acid. So in the suffix you have to put OIC and acid. The next class, that is derived from an carboxylic acid, it is an ester. It consists of 2 words. The first word is the name of an alkyl group which is attached to an oxygen atom, and second word is derived from a carboxylic acid name. So replace just IC to it. IC acid to it. When we are writing alkanoic acid, replace this IC acid to it. So it means an ester. And also in case of an ester, carboxylic acids, esters are derivative of an carboxylic acid. remove OH of carboxylic acid and write OR instead of that. In case of an amides, again it is a derivative of an carboxylic acid. Remove the oic acid ending from this alkanoic acid and at the end put amide. And the last class of this carbonyl compound, it is anhydrides. So change the suffix acid, just change the suffix acid, and that alkanoic it will remain same, and after that alkanoic it will have an anhydride at the last. But both ends in case of an anhydrides they are same. So thank you. We have completed classification, nomenclature and isomerism part 3, that is module number 1, lecture number 3, and lecture ID M1L3.